Okay, I think we can start. So, welcome everyone to our webinar today. This is the 11th Fenix webinar, and it's going to be an introduction to the ICEI resources at CINECA, the Italian Supercomputing Center. And we have with us today Mirko Cestari from CINECA, who is going to make a presentation. Before we go ahead, I just wanted to let you know that the webinar is being recorded so that you're aware, and the full recording will be published on our website, on the Fenix website, soon after we are done with this session. The structure of the webinar is quite straightforward. After my very short introduction now, Mirko will take over and do his presentation. We will then allow some time for a Q&A. So if you have any questions, please feel free to write them in the chat, or during the Q&A slot, you can again use the chat, or you can click on raise hand at the bottom of your Zoom window and I can unmute you so that you can ask the question out loud. And after the Q&A, I will share a couple of slides just to wrap up the session. And that's it from my side. I'm going to stop sharing now, Mirko, and I'll give the floor to you.
Hello. So let me share my screen. There you go.
Great.
Okay. Do you see it in presentation mode?
Yes, it's perfect.
So perfect. So thanks, Nicoletta. Thanks everybody for joining us today. So I want to briefly talk about our new infrastructure, which is called Galileo 100, short name G100. This has been the result of somehow long process, as it always the case with this kind of system provisioning. But we are very proud of the result. I think we definitely are looking forward to see how capable is this new system. So as I hinted, this was somehow long process that started with the drafting of the common technical specification. So all the partners of this project combine their knowledge in order to assess what the scientific community, specifically in this case Human Brain Project, wanted to achieve with these new hardware infrastructures. So CINECA took the chance to draft the specification for the Galileo 100. We started the procurement actually at the end, I would say, of 2019. Lasted basically 1 year, and the contract was awarded beginning of this year, 2021. And then the system started to be delivered, installed, and is basically now set up and ready for the pre-production. So again, the goal of the system, I would say, then we will go a little bit more deeper into details. CINECA has elected to basically provision a system with a clearly devoted to data analysis and storing of data. So we provide a system with larger memory servers and also GPU servers for data analysis. This system in itself is what we call, or in terms of praise, if you want, labeling, our tier 1 system. So it's not our flagship system, but with this system we wanted to have a model that we can use in the future for systems that can host different services, computing services and storage services. So in particular, we wanted to have a system able to host mid-sized parallel workloads, and so as interactive computing services and in general flexible computing, meaning here cloud computing services. The system is very balanced in terms of computing and storage, and as I said, is the services hosted in the system are tightly coupled. So the system overview is this one. So from top to bottom, top is the compute part. So we have the cloud partition that is based on 77 nodes, with each with 700 gigs of RAM. This will host the OpenStack instance to provide cloud services. So on the right, we have the more traditional, if you want, HPC partition, but here a little bit diverse. So we have, if you want, islands with thin nodes, GPU nodes, and fat nodes. The interconnection is InfiniBand for the scalable and interactive compute partition, and Ethernet for the cloud compute. We have a gateways between the two interconnections, and then on the bottom of this picture, you see the storage ecosystem. So we have cloud storage, which will provide the Ceph specifically for the cloud computing. So at the end, it will be something in the order of 700 terabytes, but this is a full flash. So able to host also databases or anything that is really intense of IOPS. On the right part, we have the hot storage, meaning the storage that aims to host the data analysis. And we have roughly slightly over 20 petabytes net capacity. We have data services nodes specifically for exporting data towards the outside. We will see that a little bit later. And this orange stands from an IO enhancer, I would call it, that aims to basically provide a better performance for IO that is requested from all the scalable interactive computing clients. So all sorts of different possibility can be covered. So we somehow envision that a project, maybe a huge project requiring multiple computing and service and storage services can leverage, I don't know, the cloud partition to host virtual machines that maybe expose data that are both on the cloud cloud storage or the hot storage of the system. Maybe the project needs also to use the GPU for data analysis and can access this partition as well. So again, all sorts of this different combination can be achieved, and this is why I said that we are really proud and somehow very eager to understand the capability of the system. This is just more of the same. The scalable compute and interactive compute partition, they share in principle the same servers. So at least from the beginning of the production, we don't reserve specific resources for one or the other. We share them between the two services, and then we let the workload manager to be able to address the needs from the users. A little bit more about the user environment. So this is typical for all our systems. So user can access can establish a login interactive sessions, which are limited to 10 minutes of CPU time, and this is are typically aiming to serve data movement, archiving, code debugging, or development and compilation. Or batch session. This is very common for high performance computing. Everything is guided by the workload manager Slurm, and the different hardware available can be reached through partitions and quality of services. So we are defining them right now. So partition represents basically a pool of servers, while quality of service define classes of batch jobs for the same, possibly for the same partition. Available here on this website, we have the software catalog. So the software that will be available on the system for all sorts of different scientific fields that are served by the system. User can load a specific environment via the module command. Again, this is very common and typical. We also provide an utility function, an utility that is called Modmap, to basically locate and map all the modules that will be available of G100. So I recommend to use them just to see what's available on the system. Alternatively, we also provide a SPAC common environment, and users are invited to build their own software stack using SPAC. So we realized pretty much that a lot of energy goes into preparing and the productivity environment, meaning basically all libraries, tools, and applications that are available on the system, and to provide all sort of combination in terms of compiling against some libraries or against other libraries can be very taxing. So one way to do that is to provide a generic general purpose tool, which is SPAC. We have been using in production. We find it very helpful. So if you do module load SPAC, you basically set up your environment in order to use our common SPAC installation, and you are ready to download and install packages that are already available for SPAC. Now there are over 5,000 main packages, so you can have the list here. And the beauty of this is that you don't trade off any performance. So the SPAC is oriented to high performance, and so it targets, you can target specifically your hardware infrastructure, and also you can rely on community effort and use work that has been done to easily, hopefully, deploy your software stack. So we encourage to use SPAC. Cloud services, as I mentioned, is also available on the system. So the beauty of cloud is that it's basically scalable and elastic, in a sense that you can start with a pool of virtual machines, and then you realize you need more. So you can ask for more storage and so on. So this flexibility also extends not only on the computing and storing part, but also on the environment, the user environment. We will provide, as I said, we start with 77 OpenStack compute servers. These are the specifics. To be noted that each server will be really rich in terms of RAM, so over 700 gigs of RAM. As I said, Ceph storage full flash of roughly 700 terabytes will serve mainly the cloud infrastructure. So this will be used to host the volumes of your so basically the hard drive, the hard disk for your virtual machines. We have nodes for the management available for public IPs, 1000 floating IP, and also completes some service nodes to manage the infrastructure. The our cloud infrastructure is available via this website, so cloudhpc.cineca.it. And after you provided the credential, you got authenticated, you will see something like that. This is the dashboard of OpenStack, where you can basically set up all sorts of different administrative configuration. So basically, our model is this one. So as CINECA, we basically provide a physical layer, as we just see, and the virtualization layer, meaning here the OpenStack. Then from this up, users take over basically. So they will install their operating system. We provide some flavors already available, but you can ask for different one, or you can use your own if you want. And then applications will be installed on top of this, relying on the Linux distribution package manager, or maybe you can compile what you need. We divided here between user admins and users, basically because user admins can, at least in our terminology, can access the dashboard that I show you, while users can only access the virtual machines. So user admins can always set multiple users to access their virtual machine infrastructure, but user admins are responsible for those users and are responsible for the project itself. So basically, these users, we don't know them because we rely on the user admins to be the proxy for CINECA of them. User guide is available here, so you can look at it and already understand how all this work. This, as I said, is how the roles are divided. So admins can create the virtual machines, can set up the network topology, maybe wants to, I don't know, 3 virtual machine, which with one as a bastion host, and so on and so forth. And then can set up multiple users for each virtual machine, and these users, of course, can access the virtual machine. So storage, as I said, we try to address also the I/O performance, and this has been done with a storage that is based on 2 tiers. One is the fast tier, and is based on IME appliances. So they are basically a layer between the computing clients and the large capacity storage. They are able to IME is in practice is a client server, so clients receive the request from the compute nodes, the IO requests, and they address them in order to basically make them more efficient towards the large capacity storage, which is below the IME layer. So in practice is a way to increase the I/O performance of the solution. Again, the storage in itself is sufficiently capacitive. So we have over 20 petabytes net. We also are looking into security features that are available with this infrastructure, specifically via Modmap. So we can provide some sort of data segregation. So basically sub-tree that are not reachable unless you are a specific UID or GID. And this can be very interesting to somehow avoid unwanted access to some data. Also, in the roadmap of a Laster-5 system, we have the data at rest encryption, and this, as soon as will be available, we will also look into it. So this is what will look like from the user viewpoint. So typically we provide some handles to user in order to let them store the data. So user will see something like that. Home is a permanent storage and backed up. Work is typically the where is stored the project data. So it has a quota, and this quota is project specific. Scratch is temporary, in a sense that can be policies are enforced in order to remove data that are older than typically 1 month, but it has no quota. So for if you dump a lot of data, or if you have simulation that dumps a lot of data, you can use Scratch. Temdir is local to the nodes, and Slurm typically deals with cleaning and set up this location for the job. So you can use it for the job, and then Slurm will clean everything. This is nice because typically this is our SSD based, so typically very with high performance. And then we have resources that are shared between the systems. We use it to store data that needs to be stored for midterm, so more than the existence of a project, which is typically in the order of 1 year. So we have what we call data resources, or DRES, and tape that, as the name says, basically is used for accessing the tape library. So the end of my presentation, we will also deploy and provide storage that can be used as an object storage service. So this is typically used to store massive amount of data, structured and unstructured, and data that can be accessed via web. So you are provided with specific API calls to access, to get and put the data, and perform all sorts of I/O calls. So this is typically used for host data that are maybe written once and read multiple times. So for example, or data that can be very, very different in nature. I don't know, you have videos, pictures, or stuff like that typically do not change, but can be read or accessed multiple times. We have 2 specific nodes that are devoted to this service, and we'll provide S3 and Swift interface for as I said, object storage service. So this is basically it.
Thank you. Thanks very much, Mirko, for your presentation. Very informative. And I think we can open the floor to any questions that people might have. So as I said in the beginning, you can write your question in the chat, or you can click on raise hand and I can unmute you. So you can ask your question out loud. But we already had one question, Mirko, during your presentation, which I took a note of. So the person is asking how many virtual GPUs are available per one V100, and if there is a special license needed to get all promised vGPUs from V100. what is the maximum number of virtual machines on one server with vGPU?
So they from the start we will start with the OpenStack partition will so the cloud partition will not provide any GPUs, but we can actually integrate the cloud partition with the GPU servers. The GPU servers is a kit with 2 GPUs each. Regarding the V100 virtualizer, I'm not so sure because we haven't done this, so we need to check this and get back to you. So if you want to drop me an email, we will check this.
Thank you. Okay. Then we have one more question that just came in that says, are there cloud nodes with GPU?
Yeah, as I said, this is to my point, my previous point, not yet. In a sense, not we won't start with this, but we are of course considering to integrate this part in the future, maybe already with including servers that are already available. So we will start as a clean. So we will use the GPU partition for interactive computing in a sense of accessibility as learn. So because I haven't mentioned this, but basically we are also procure a solution for interactive computing. So we'll probably use those GPU nodes with a solution that we are procuring. So not the cloud, but in principle we can integrate those servers in the cloud partition. So.
Great, thank you.
So basically, the node is designed as such. We can do this. So as all the Ethernet interfaces and so on. So.
Right. Okay, thanks. 2 more questions. The first one says, will it be possible to have long run on Slarm where we can run long commands, for example, more than 24 hours?
So yeah, 24 hours is typical our threshold, but I mean we can address requests, but just maybe for a short period of time or via a specific QoS, as I mentioned. So this can be done. We require typically the user to describe the need and trying to maybe emphasize why they are forced to do so. Maybe they cannot rely on a checkpoint restart or some sort of way to avoid this, and we will address it.
Because the person says that it will be useful for genomic studies, for example. So we have to justify the purpose. Okay.
Well, so the other way is to use a cloud project. So with a cloud project, you can basically have access to resources. It depends on which resource you need. So if you need the parallel, so if you go over multiple server nodes, so with parallel jobs. Otherwise, if you rely just on one node, one compute node, you can use a cloud project and run your simulation for as much as you like.
Okay, another question. Will there be any Kubernetes provisioning possible?
So this is actually a proof of concept that we are running, in fact, on this system. So we will probably use some of these nodes to run this proof of concept, and see what we can get from this test. So we are working on this, and actually I think that this can be a really viable solution, specifically for such systems that try to address multiple user requests.
Thank you. Okay, a few more questions came. Another one says, is it possible to have provisional budget to set the correct parameters, number of cores, etc., before start consuming the assigned one?
So we provide what we call try project. Trial, they are basically trials that you, with a really small amount of, and these are for free. So you can just ask, drop an email, and you'll be provided with some sort of this. So you can use this very temporary project to set up your environment and and tune your applications. This is one way. Other ways are within maybe the praise course. So you can, I think, access to specific projects to do so. We also have the, I think, capability to run jobs without using the budget, but this is typically when your budget is reaches the end, and you can use it, but the jobs are preemptible, so it can be killed anytime.
Right, that makes sense. Another one, another question says about cloud-based storage, how the QoS policy is managed. For instance, is there the possibility for a user to set a minimum guaranteed amount of IOPS to a virtual machine volume?
I'm not sure about this. I'm not sure if you can set up a QoS. It depends on what basically OpenStack can provide, because we rely on the last stable version of OpenStack to basically provide you all the features. So I don't know if there's such a QoS. In terms of hardware, the hardware is there in the sense that it is full SSD. So hopefully should serve the enough IOPS. But then we need to check the details and see if everything works. But in principle, the hardware should be enough to serve the user needs also for IIOps workloads.
Thank you. And a question says, will job allocations allow shared node usage, or an entire node and possibly multiples will be allocated for its job?
So we can have, I think we can have both approaches. I think we rely on not exclusive jobs for the thin nodes and the fat nodes, but the GPU nodes will be probably run with exclusive jobs. But this is still work in progress. So I'll recommend to check our user guide for all this setup.
Thanks very much, Mirko. Okay, maybe the last question just came in that says, in what year Fenix Research Infrastructure project will end, and what percentage of Galileo 100 is devoted to Fenix Research Infrastructure?
So I think that the end date is end of March 2023.
That's correct, yeah.
And I don't know. There's some consideration in extending it, but it's just officially end of March. And the percentage of Galileo 100 is 25% for human brain, and considering both computing and storage.
Mm-hmm. Thank you. Okay, I think we had a very lively Q&A slot. We had a lot of questions that came in. Maybe at this point we can wrap up the Q&A, and I can share a couple of final slides that I think will be interesting.
Yeah, if I may, Nicoletta, just because
sure.
I haven't actually. So we can be reached since we received a lot of questions. We can be reached via this email address, which is super, as in Superman, C, all so super C at cineca.it. So superc@cineca.it is the email for accessing our user support, and you can ask whatever question you have.
Perfect. I've shared this in the chat, so it's superc@cineca.
Yeah, I can do that if you want to take over. Then
great. Thank you. Thanks. Okay, I'll take over. Mirko, thanks very much for this presentation. I would really like to thank you for presenting for us today. So before we finish, and before thanking our attendees too for joining us today, I'd like to share a few points about how to access all these resources that Mirko talked about and the rest of the Fenix services. So there are different ways to access the resources. If you're a neuroscientist, then we have a Human Brain Project /eBrains call that is ongoing with no deadline, and you can submit your application and have access to our resources through that way. Then another way is the PRAISE ICEI calls for proposals, which are quarterly. And actually at the moment, the 6th call is running. The deadline to submit a proposal is the 9th of July. So please have a look at our announcement on the website for this. It's a quite straightforward procedure. You just submit an application of some it's a Word file of a few pages, and then the PRAISE review committee will review this proposal before the allocation. All details can be found on our website. You can have a look at my slide here, but I will also share all these links with you in an email that you will receive tomorrow. So don't worry about that. Then, before I finish, it would be great if we have your feedback for this session today. A link will open on your browser right after this webinar. So if you can just take a couple of minutes to respond to our survey, that would be great. And finally, some information about how to stay in tune with our activities. We have the Fenix User Forum, which is an online platform for current or potential Fenix users to join. You can ask questions on there, you can share your experiences, and the Fenix experts will be more than happy to help you. The next event of Fenix is our Fenix User Forum Virtual Cafe. It's the second edition of this virtual cafe we're running. This takes place on Tuesday, 6th of July. There is again information on our website, but you will also receive the link for this in this email I mentioned before that is coming to you tomorrow. For any questions, you can either email the email address that Mirko mentioned for the CINECA resource in particular, or you can email us at our general ICEI email address you see here. I mentioned our website with all the information that you might need, and you can also follow us on Twitter and LinkedIn to stay in touch with everything we do. That's all from our side, I think. Again, thanks very much, Mirko, for your presentation and for answering all these questions today. And thank you everyone for attending. Stay tuned for the full recording and presentation slides to be posted on our website very soon. Thank you.
Thank you, everybody.